In 2011, Ford did something no one expected. They brought back the 5.0 badge on a completely new engine that shared nothing with the legendary original. The Coyote wasn't a tribute, it was a revolution wrapped in nostalgia. Critics called it impossible, engineers called it overdue. Buyers called it the reason they'd finally trade in their 2005 GTs. But how did a clean sheet design reverse 15 years of Mustang decline? And what engineering gamble made Ford bet the farm on an engine most accountants wanted killed? Stay with me till the end, because this might surprise you. April 2009. A prototype Mustang GT sat idling in Ford's Dearborn test facility, and the numbers on the dynamometer screen didn't make sense. 412 horsepower, 390 pound-feet of torque, from a naturally aspirated 5-liter V8, designed to meet California emissions and average 30 miles per gallon on the highway. The Coyote had just made more power than the outgoing 3-valve 4.6, burned less fuel, and did it while spinning to 7,000 RPM with factory warranty coverage. Tom Barnes, Ford's powertrain chief engineer, watched the screen and knew they'd crossed a line. The Mustang hadn't been truly competitive since the Fox body era ended. The retro-styled 2005 model sold on looks and heritage, but its engine was a parts bin compromise. Chevy's LS3 made more power. Dodge's Hemi sounded meaner. The Mustang was falling behind in the only war that mattered, the one fought at every stoplight and drag strip across America. The Coyote changed that calculation, but it didn't arrive by accident. This engine represented a fundamental shift in Ford's philosophy, a rejection of the incremental updates and cost-cutting that had defined their V8 strategy since the mid-90s. Instead of modifying the aging modular platform one more time, Ford's engineers started over. They designed an engine specifically for performance, then engineered the emissions compliance and fuel economy around it. That decision violated decades of corporate thinking. It also violated the budget. Development costs ran beyond projections. Manufacturing tooling required complete facility overhauls. The business case kept getting thinner as the financial crisis hit and Ford burned through cash reserves. Twice, executive committees discussed killing the program and sticking with the existing engine. Twice, the engineering team argued that without the Coyote, the Mustang would lose its last competitive advantage. The dynamometer run in April proved them right. The engine delivered. But that victory opened a new question. Could Ford actually build it in volume, price it competitively, and convince buyers that an all-new 5.0 was worth the premium over cheaper alternatives? The next 18 months would answer that question with brutal clarity. Beyond the raw numbers, the Coyote represented something deeper. American manufacturers had spent a decade letting European and Japanese brands define what modern performance meant. Variable valve timing, high revving designs, sophisticated engine management systems. These were technologies developed overseas and licensed reluctantly by Detroit. The Coyote flipped that story. Twin independent variable camshaft timing, forged internals, drive-by-wire throttle control, plasma-transferred wire arc cylinder bore coating. This was American engineering using global best practices without apology. When the prototype left the dyno that afternoon, Barnes called his team together. The hard part was over. The engine worked. Now they just had to convince the world it mattered. To understand how that moment became possible, we need to go back to the world that created it. The year was 1996, and Ford's modular engine family was supposed to be the future. The 4.6-liter V8 replaced the ancient 5.0 Windsor design with overhead cams, modern architecture, and a platform flexible enough to scale across the entire Ford and Lincoln lineup. The business case made perfect sense. One basic engine design, multiple displacements, shared tooling, reduced costs. The Mustang GT got the 2-valve version making 215 horsepower, adequate for the time, but hardly inspiring. That adequacy became a problem. Between 1996 and 2010, the modular 4.6 received incremental updates. A 3-valve head in 2005, variable cam timing in some applications, improved intake manifolds. Power crept upward. The 2010 GT made 315 horsepower, a 50% increase over the original. But each update meant working within the constraints of an aging architecture designed for luxury sedans, not sustained high RPM abuse. Meanwhile, the competition evolved faster. General Motors introduced the LS1 in 1997, a clean-sheet pushrod design that made more power from similar displacement while weighing less and packaging tighter. The LS platform became modular in the way Ford's engine never quite managed, spawning variants from truck motors to Corvette exotics. Chrysler brought back the Hemi name in 2003 with an engine that prioritized torque and soundtrack over outright efficiency. Both competitors had found their identity. Ford's Mustang was stuck with a corporate compromise. The enthusiast community noticed. Internet forums filled with comparisons showing the Mustang losing drag races, falling behind in magazine tests, and requiring more modification to match factory Camaro and Challenger performance. The retro styling that revived Mustang sales in 2005 bought Ford time, but styling couldn't overcome 40 fewer horsepower and an engine that felt strangled above 5,000 RPM. Owners swapped in superchargers, aftermarket heads, and custom tuning just to keep pace. Inside Ford, engineers knew the problem but faced institutional resistance. Developing a new V8 meant allocating resources during a period when the company was hemorrhaging money. The modular engine worked well enough in F-150s and Explorers. Why spend hundreds of millions on a performance variant that would sell a fraction of the volume? The business case for an all-new Mustang engine didn't exist on any spreadsheet that mattered to corporate finance. Then two things changed. First, Ford declined the government bailout in 2009, betting the company's survival on products in development. That decision created pressure to prove Ford could innovate without taxpayer support. Second, Chevrolet announced the fifth-generation Camaro with an LS3 engine making 426 horsepower. If the Mustang couldn't match that number, it would lose the performance crown it had held intermittently for 5 decades. Tom Barnes saw the opening. He'd spent his career at Ford working on engine programs, most of which involved optimizing existing designs for cost or emissions. The Coyote would be different. Barnes assembled a team and made a pitch. Give us the budget to design the engine the Mustang deserved, not the engine the accountants preferred. The pitch worked, barely. Development funding came through in late 2007 with production targets set for 2011. That gave the team less than 4 years to design, test, and manufacture an engine that would either save the Mustang or prove Ford had lost its performance edge forever. The pressure wasn't just internal. The automotive press had begun writing obituaries for the American V8. Fuel economy regulations were tightening. Turbocharged 4 cylinders and hybrid systems dominated engineering conferences. Building a large displacement, naturally aspirated performance engine looked like denial of reality. Barnes and his team had to prove that modern technology could make the traditional American V8 relevant in an era that seemed determined to replace it. The central tension wasn't just technical, it was philosophical. Could American muscle survive the 21st century? The Coyote started with a mandate, 7,000 RPM. That single specification dictated every component choice. The old modular 4.6 topped out around 6,000 revs before valve float and harmonics became problematic. Higher RPM meant more power from the same displacement, but it also meant rethinking every stressed component. Ford's engineers began with the cylinder block. The Coyote used a deep skirt design with cross-bolted main-bearing caps providing rigidity similar to race engines. The block itself was cast aluminum with plasma-transferred wire arc coating applied directly to the cylinder bores, eliminating cast iron liners and saving nearly 40 pounds. That coating process, borrowed from diesel and racing, applications provided a harder surface than traditional iron sleeves while allowing tighter piston-to-wall clearances for reduced friction. The crankshaft received similar attention, forged steel instead of cast iron. Each crank was individually balanced to reduce vibration at high RPM. The connecting rods were powder forged, a manufacturing process that created stronger grain structure than traditional forging. Pistons used a modern skirt design that reduced weight while maintaining strength, each one coated to minimize friction against those plasma-coated cylinder walls. But the real innovation sat in the cylinder heads. Ford designed a 4-valve per cylinder layout with twin independent variable camshaft timing, a system that could adjust intake and exhaust cam phasing independently across the entire RPM range. According to period testing, this system improved low-end torque by up to 20% while maintaining high RPM power, solving the traditional compromise between bottom-end grunt and top-end horsepower. The intake manifold used a composite material that improved airflow while reducing heat soak. Each runner was tuned for specific RPM ranges, creating multiple power bands across the rev range. The throttle body measured 82 millimeters, larger than the outgoing engine, but still sized to maintain air velocity at part throttle for drivability. Ford's approach to the valve train revealed their commitment to durability. Roller finger followers reduced friction compared to traditional rocker arms. Hydraulic lash adjusters eliminated the need for periodic valve adjustments, making the engine owner friendly despite its high performance capability. The camshafts themselves used aggressive profiles that would have caused idle quality issues in older designs, but the variable timing system masked that aggression during normal driving. The engine management system represented a generational leap. Drive-by-wire throttle control allowed precise coordination between throttle position, cam timing, and ignition advance. The computer could adjust all three parameters hundreds of times per second, optimizing for power, efficiency, or emissions depending on driving conditions. This level of control made it possible to meet emissions standards while still producing big power, something that would have been impossible with mechanical systems. Cooling received obsessive attention. The Coyote generated more heat than its predecessor, especially during sustained high RPM operation. Ford designed a coolant crossover passage that improved flow to the back cylinders, eliminating hot spots that plagued earlier modular engines. The oil system used a high-capacity pump with pressure relief valves that prevented cavitation during hard cornering or acceleration. One detail separated the Coyote from corporate engines, the redline. Ford programmed a 7,000 RPM fuel cutoff, with power peaks around 6,500 revs. That number had symbolic weight. European performance engines routinely rev to 8,000 or 9,000 RPM, but they use small displacements and exotic materials. The Coyote proved that a 5-liter American V8 could spin fast enough to make power like a smaller engine while retaining the torque and character enthusiasts expected. The result was an engine that made 412 horsepower and 390 pound-feet of torque in stock form, numbers that exceeded the LS3 on a per-liter basis. More importantly, the power delivery felt different from the old modular engine. Where the 4.63 valve hit a wall above 5,000 RPM, the Coyote pulled hard right to redline. The engine felt willing, responsive, eager to rev in a way American V8s traditionally didn't. But every revolution has its breaking point, and this one was about to face its own. February 2010. Ford's manufacturing team gathered in the Romeo engine plant outside Detroit, and the news wasn't good. The Coyote's complex assembly process was running 30% slower than projected. Every engine required more hand fitting than anticipated. The plasma coating process created variances that demanded individual piston selection for each cylinder. Quality control rejected motors at twice the expected rate. At current production speeds, Ford couldn't build enough engines to meet demand forecasts for the 2011 Mustang launch. The problem stemmed from ambition. Ford had designed an engine with tolerances and complexity beyond their normal manufacturing capability. The plasma-coated cylinders that saved weight required new measurement equipment and trained technicians who could interpret the data. The variable valve timing system used components from multiple suppliers who'd never coordinated on a single engine program before. Assembly line workers accustomed to building simple truck motors now faced an engine with 60% more parts and half the tolerance for error. Tom Barnes faced a choice. He could simplify the engine, removing the most complex components to speed production. That would mean reverting to fixed cam timing, using conventional cylinder liners, accepting lower performance targets. The Coyote would still be better than the outgoing engine, but it wouldn't be the leap forward Ford had promised. Or he could bet on the manufacturing team solving the problems, risking production delays and cost overruns that would make the entire program look like a mistake. The pressure came from multiple directions. Finance wanted simpler engines that could be built profitably. Marketing needed engines in dealers by spring 2011 to compete with the new Camaro. The Mustang team had already committed to performance numbers in press releases and advertising materials. Walking back those claims would damage Ford's credibility with the enthusiast community it was trying to win back. Barnes chose to push forward. He moved experienced engineers from other programs to Romeo, giving them authority to modify the assembly process on the fly. Ford invested in additional training and new tooling specifically for the Coyote's unique requirements. The company ate the cost overruns, betting that success would justify the expense, but production problems weren't the only crisis. As Coyote-powered Mustangs reached pre-production testing, a pattern emerged. Engines were breaking valve springs at high mileage, particularly in sustained high RPM operation. The springs Ford had selected were adequate for normal use, but marginal for the abuse enthusiasts would inflict. Changing springs meant redesigning the valve train package, revalidating the entire engine, and potentially delaying launch. The valve spring issue exposed a deeper tension in the Coyote's design philosophy. Ford had built an engine that could rev to 7,000 RPM, but was it actually engineered for repeated use at those speeds with warranty coverage? The marketing message promised track-capable performance. The bean counters wanted durability testing that assumed normal street driving. Those two goals didn't align. According to engineering reports from that period, Ford made a critical decision. They upgraded the valve springs, strengthened several related components, and increased the durability testing cycle. Launch would be delayed by 2 months, but the engine would be engineered for the abuse it invited. That choice cost money and created chaos in the supply chain, but it reflected a commitment to building the engine right rather than building it fast. Meanwhile, Chevrolet wasn't sitting still. GM announced that the 2012 Camaro would receive the LS3 with upgraded exhaust, pushing output to 426 horsepower. Ford's 412 suddenly looked less impressive. The engineering team lobbied for more aggressive tuning, but emissions certification had already been completed. Changing the tune meant restarting that process, another delay Ford couldn't afford. Internal corporate politics added another layer of complexity. Ford's truck division questioned why the Mustang received an expensive new engine, while F-150 continued with updated versions of older designs. Resources were finite, and the Coyote consumed a disproportionate share of engineering bandwidth. Every meeting included questions about whether the Mustang investment would generate sufficient return compared to allocating those resources elsewhere. The crisis reached its peak in June 2010. Manufacturing was still behind schedule. Quality issues persisted. The valve spring redesign had consumed the last buffer in the timeline, and Dodge announced that the Challenger SRT-8 would receive a 6.4-liter Hemi, making 470 horsepower, making the Mustang look underpowered before it even launched. The business case for the Coyote, already questionable, seemed to be collapsing. Barnes and his team worked 100-hour weeks through the summer. They fixed problems as they arose, made compromises where necessary, and refused to compromise where it mattered. By September, production had stabilized. By November, engines were shipping to the Flat Rock assembly plant where Mustangs were built. The Coyote had survived, but barely. Could it have survived if the world wasn't ready? The first customer cars reached dealers in March 2011, and the reception shocked everyone. Motor Trend called the Coyote the best naturally aspirated V8 in America. Car and Driver praised the power delivery and high RPM willingness. Enthusiast magazines ran comparison tests showing the Mustang GT matching or beating the Camaro SS in most performance metrics despite the horsepower deficit. The engine's responsiveness and willingness to rev compensated for the raw numbers disadvantage. Sales data told the same story. Mustang GT orders doubled compared to the previous year. Buyers specifically cited the Coyote as the reason for purchase, often mentioning that they'd cross-shopped Camaros but preferred the Ford's power delivery and sound. The 5.0 badge carried enough nostalgia value to overcome its lack of historical connection to the Windsor engine it replaced. To buyers, 5.0 meant Mustang performance regardless of technical lineage. Drag strip results validated Ford's engineering choices. Stock Coyote Mustangs ran consistent 12 second-quarter miles with minimal modification. The engine responded well to tuning, with bolt-on modifications adding 50 or more horsepower without compromising reliability. According to racer commentary from that period, the Coyote felt more like a factory race engine than a street motor, capable of repeated high RPM abuse without the fragility that plagued earlier performance Fords. The automotive press noticed details that casual buyers missed. The Coyote's oil pressure remained stable during sustained cornering. Coolant temperatures stayed controlled during track sessions. The engine didn't experience the valve float or timing chain issues that had affected the 3-valve modular engine under hard use. Ford had engineered the durability to match the performance, something American manufacturers traditionally struggled to achieve. Dealer experiences reflected the enthusiasm. Service departments reported minimal warranty claims on Coyote engines. The owners who did bring cars in typically needed adjustments or software updates rather than major repairs. The engines were proving reliable even in hands of buyers who used them hard. That reputation for durability became part of the Coyote's legend, encouraging buyers who'd been burned by fragile performance cars in the past. But the contrast between promise and outcome wasn't entirely positive. The Coyote-powered Mustang still trailed the Camaro SS in straight-line acceleration. The UI horsepower deficit mattered less on paper than on the street, but it mattered. Ford's marketing emphasized driver engagement and handling balance, classic talking points for cars that didn't make the most power. Some reviewers questioned whether Ford should have turbocharged the engine or increased displacement to match the LS3's output. Public perception split along predictable lines. Mustang loyalists celebrated the Coyote as proof that Ford could still build proper performance engines. GM fans pointed to the spec sheets and argued that pushrod simplicity beat overhead cam complexity when power numbers were close. Dodge owners dismissed both engines as inadequate compared to Hemi torque. The bench racing arguments that define muscle car culture continued, but now the Mustang had a credible engine to defend. Press reactions revealed another truth. The Coyote's real competition wasn't the LS3 or the Hemi. It was the turbocharged future everyone saw coming. Reviews frequently mentioned that the Coyote might be the last clean-sheet, naturally aspirated American V8, designed without forced induction as a crutch. That context made the engine feel both triumphant and sad, a final perfection of a dying breed. Within Ford, the mood was vindicated relief. The Coyote had worked. Sales justified the investment. The manufacturing problems were solved. The Mustang was competitive again, but everyone understood that this victory was temporary. Fuel economy regulations would continue tightening. Emission standards would grow stricter. The naturally aspirated V8 had a limited future, no matter how good the engineering. The Coyote bought Ford time to develop whatever came next, time they desperately needed. Tom Barnes and his team received internal recognition but little public credit. That was typical for engineers whose work only became visible when it failed. The Coyote's success meant most buyers never thought about the decisions and compromises that made it possible. They just knew the Mustang felt right again, sounded right, drove right. That anonymous satisfaction was the highest compliment engineering could receive, but history has a habit of rediscovering what it once discarded. Over the following decade, the Coyote evolved beyond its original mission. Ford introduced a second generation in 2015, increasing displacement to 5.2 liters and output to 460 horsepower. The Gen 2 used strengthened internals and improved cylinder heads while maintaining the basic architecture. A third generation appeared in 2018 with direct fuel injection added to the existing port injection, creating a dual injection system that improved power and efficiency. By 2020, the Coyote made 480 horsepower in GT trim, nearly 70 more than the original. Each evolution proved the original architecture's flexibility. The Coyote platform became Ford's performance foundation, spawning variants from truck motors to the supercharged Predator engine in the GT500, making 760 horsepower. The basic design that Barnes and his team created in 2007 remained relevant 15 years later, continuously improved but fundamentally unchanged. That longevity justified every dollar Ford had invested. The aftermarket embraced the Coyote with enthusiasm unusual for a modern engine. Tuners developed forced induction kits that reliably produced over 1,000 horsepower. Engine builders offered stroker kits that increased displacement to 5.4 or 5.8 liters. The forged internals and strong block made the Coyote nearly bulletproof when built properly. According to builders who specialized in the platform, the Coyote responded to modification better than any Ford V8 since the Windsor small block. That modification culture created a restoration economy. As early Coyote Mustangs aged, specialist shops emerged offering rebuild services, performance upgrades, and maintenance programs. The engines proved durable enough that high-mileage examples could be refreshed and returned to like-new condition. Some owners performed their own work, appreciating that modern complexity hadn't eliminated the possibility of home garage maintenance. Collector culture developed differently than with classic Mustangs. The 2011 to 2014 Coyote cars weren't yet old enough to be truly collectible, but enthusiasts recognized their significance. First-year production cars with low mileage commanded premiums. Special editions like the Boss 302, which used a track-tuned Coyote making 444 horsepower, became particularly desirable. The market understood that these cars represented a turning point, the moment when the Mustang became competitive again. Modern reinterpretations of the Coyote appeared in unexpected places. Ford's Performance Parts division offered the engine as a crate motor, allowing builders to drop Coyote power into classic Mustangs, hot rods, and kit cars. The combination of modern reliability and classic styling created resto-mod builds that bridged generations. A 1967 fastback with Coyote power could drive across the country, then run competitive lap times at track days without braking. The Coyote's relevance extended into debates about the automotive future. As manufacturers shifted toward turbocharged engines, hybrids, and eventually EVs, the Coyote represented the road not taken. It proved that naturally aspirated engines could meet modern emissions and efficiency standards while delivering genuine performance. That accomplishment made the industry's wholesale abandonment of the concept feel premature, driven more by regulatory pressure than technical limitation. The sound became part of the legacy. The Coyote had a distinct exhaust note, more aggressive than the modular engine but less raw than classic American V8s. It howled approaching redline in a way modern turbo engines couldn't match. That soundtrack became synonymous with modern Mustang performance, immediately recognizable to enthusiasts even without seeing the car. In an era when electric vehicles offered silent acceleration, the Coyote's mechanical symphony felt increasingly precious. Engineering students and professionals studied the Coyote as a case study in modern engine design. Universities used it as an example of how to integrate variable valve timing, direct injection, and sophisticated engine management without compromising the character that made performance engines desirable. The Coyote proved that technology could enhance rather than replace mechanical involvement, a lesson that applied beyond automotive engineering. What was gained exceeded expectations. The Coyote saved the Mustang's competitiveness during a critical period. It established Ford's credibility in performance engineering. It created a platform that would remain relevant for decades. What was lost was less tangible, but equally real. The Coyote couldn't sound like the Windsor 5.0, couldn't match that engine's raw simplicity, couldn't deliver the direct mechanical connection that came from older technology. It was a better engine by every objective measure, but it represented a different philosophy of what performance meant. The craftsmanship that went into the Coyote was mostly invisible. Hidden inside that engine were thousands of decisions about materials, tolerances, manufacturing processes, and validation testing. Each decision reflected someone's expertise and judgment. The plasma-coated cylinders that saved weight required mastering a process most manufacturers didn't attempt. The variable cam timing system demanded precise coordination between mechanical and electronic systems. That invisible complexity was what separated the Coyote from engines that looked similar on paper but felt different to drive. The sound of that engine wasn't just horsepower, it was defiance cast in aluminum. Defiance against declining performance, against corporate compromise, against the assumption that American manufacturers couldn't match import sophistication. What began as an experiment became a legend long after the factories went quiet. We returned to that prototype sitting in Ford's Dearborn test facility. Dynamometer readout showing numbers that shouldn't have been possible. 412 horsepower from a naturally aspirated 5-liter V8 that met every emission standard and averaged 30 miles per gallon. Tom Barnes looking at that screen and knowing they'd done it, knowing the Mustang would survive. The Coyote meant more than horsepower figures. It represented a belief that American performance engineering could compete globally without apology. It proved that modern technology enhanced, rather than compromised, the visceral experience of driving a powerful car. It showed that doing things right, even when harder and more expensive, created value that justified the cost. Today, the Coyote remains in production, 15 years after that first prototype proved the concept. It powers Mustangs, trucks, and specialty vehicles. It sits in garages, waiting for weekend drives and track days. It defines modern American performance in a way few engines achieve. The 5.0 badge that once meant Windsor now means Coyote, a transition that honors history while creating new legends. The lesson isn't about engines or horsepower, it's about institutional courage. Barnes and his team could have taken the safe path, incremental improvements to existing designs, adequate performance at lower cost. Instead, they argued for revolution, risked their reputations, and built the engine the Mustang deserved, rather than the engine accountants preferred. That kind of courage is rare in corporate environments designed to minimize risk. The Coyote saved the Mustang by giving it the one thing styling couldn't provide: genuine performance credibility. It turned the Mustang from a nostalgic styling exercise into a legitimate sports car. It brought back buyers who'd abandoned Ford for faster alternatives. It reminded enthusiasts that American engineers could build world-class engines when given the resources and freedom to do it right. If you've ever driven a Coyote-powered Mustang, if you've felt that engine pull hard to 7,000 RPM, if you've heard that exhaust note bouncing off canyon walls or echoing down drag strips, share your story in the comments. These engines created experiences that numbers alone can't capture. They connected drivers to a tradition of American performance that seemed threatened but refused to die. The Coyote wasn't perfect. It didn't make the most power in its class. It couldn't match the low-end torque of larger engines or the efficiency of turbocharged alternatives. But it delivered something more important, the feeling that driving still mattered, that performance was about more than acceleration times, that an engine could have character and sophistication simultaneously. Looking forward, the Coyote's future is uncertain. Ford has announced plans for hybrid and electric Mustangs. Regulations continue tightening. The naturally aspirated V8 becomes less commercially viable each year. But the Coyote has already earned its place in automotive history. It proved what was possible when engineers cared more about excellence than adequate, when companies invested in performance even during financial crisis, when doing it right mattered more than doing it cheap. The cold morning at that Dearborn test facility changed everything, not because of the numbers on the screen, but because of what those numbers represented. They represented belief that performance engineering still mattered. They represented commitment to building cars that enthusiasts would cherish. They represented the idea that American automotive culture, written off by critics and threatened by changing times, still had something essential to offer the world. Thanks for watching, and I'll see you in the next video.